At the Port of Honolulu, the hub of Hawaii's commercial harbors system, Marine Terminal Operator Hawaii Stevedores Incorporated handles the cargo for carriers such as Pasha Hawaii, Ocean Network Express, CMA CGM, and others, which transport essential shipments that support every aspect of life in Hawaii, including food, medicine, commercial goods, construction materials, fuel, and vehicles. The challenge is that disruptive events such as hurricanes, fires, or equipment failures place the port at risk of power outages, which could halt operations and cut off key supplies to the Hawaiian Islands. At the request of the U.S. Department of Energy, the National Laboratory of the Rockies conducted a study to understand how electrifying the port's new Kapalama Container Terminal, or KCT, could allow shipments to continue moving through the port during a 36-hour outage, a measure that could potentially strengthen the port's energy security. KCT was built by the Hawaii Department of Transportation and is operated by Hawaii Stevedores Incorporated. The terminal operators ultimately hope to be able to unload one ship using 2 cranes without grid power, relying instead on a microgrid with distributed energy resources to support those operations. NLR researchers worked with Hawaii Stevedores to understand how advanced energy technologies, including crane regenerative energy and battery energy storage systems, could keep critical infrastructure at KCT running at a reduced load in a state called island mode during outages. KCT has 5 buildings: an administration building, a marine operations building, a maintenance shop, a break room, and guard room, and 2 out of 5 large ship-to-shore cranes that must operate regularly and especially during emergencies to maintain operations consistently. The NLR team simulated the facility's operations to represent electric demand and forecasted energy needs to power KCT's equipment. Researchers used NLR's REOPT tool to estimate sizing for energy generation assets and backup battery energy storage systems needed to power KCT's essential facilities and support on-site operations during normal operating conditions, as well as in island mode when the grid system is disrupted. The operators are planning to integrate electric cranes with regeneration technology at the facility. Future analysis could explore how the cranes might affect the electrical and microgrid systems. Although power outages will inevitably interrupt operations at the Port of Honolulu, microgrids with energy storage could provide the energy security and reliability required to keep the Hawaii Stevedores Container Terminal operational and allow carriers to continue delivering life and health-sustaining goods to Hawaii's residents through any grid outage. As ports across the United States are looking to shore up their own operations through advanced energy technologies, Honolulu's KCT could pave the way as a leader in advanced and secure energy systems and show other ports how to keep shipments moving independently of grid power.